The Scientific Method by Nicole Verdone, Sonia Hansen, and Carrie Ann Engesser. The scientific method was created by a combination of different scientists during the Renaissance and Enlightenment period, who continuously altered the previous model. Some speculate that Greek philosophers such as Aristotle created the method, but they cannot take all the credit. Aristotle can be credited with founding empirical science, which is based off of evidence, and your hypothesis must be able to be tested using observation and experimentation. Modern scholars were credited with refining the scientific process, but Isaac Newton was the first person to understand that the scientific method must include induction as well as deduction. The idea of inductive reasoning, which is when you go from a specific observation to a broad generalization, was first added to the scientific method by Francis Bacon. The scientific method is an ongoing process. The steps are making an observation, thinking of a question, doing research, making a hypothesis, doing an experiment, recording results, and repeating the experiment. The process, however, is not finite, and alterations can be made to it. A primary source is a good example of the steps to the scientific method. One primary source is the ecological conditions that favor tool use and innovation in wild bottlenose dolphins. Eric M. Patterson and Janet Mann did a study on bottlenose dolphins to determine why they use sponges as tools to find prey, whereas other species of dolphins only use.
The question is based off of what is observed and is the driving force behind the experiment. In this experiment, the question is, why do bottlenose dolphins continuously probe the substrate while searching for prey? Research happens after you have come up with a question you need to gather information on the topic you would like to make an experiment on. The research can be from scientific journals or previous experiments on this topic. An observation is the process of seeing something to gain information. In the experiment, they observed bottlenose dolphins using sponges as tools.
A hypothesis is a broad scientific statement saying what you believe the outcome will be. The hypothesis in the experiment was that dolphins that use sponges to probe the substrate do so because they target prey without swim bladders and they are hard to detect without echolocation. Hypotheses must be falsifiable and cannot be proven, but they can be disproven.
Okay.
A prediction develops an idea of what you think the outcome of the experiment will be if your hypothesis is correct. In the experiment, the prediction was that the majority of prey that sponges encounter will lack swim bladders. A good experiment has a control group which does not receive experimentation. An experimental group is the group that receives the variable being tested. An independent variable is a variable that you manipulate during the experiment. It is what you think will affect the dependent variable. A dependent variable is what the independent variable affects and what you measure in the experiment. Sometimes an experiment is just observing something to better understand it and does not contain all the aspects of a traditional experiment. When concluding, we evaluate the data, conclude what the trend of the data was, and either accept or reject the hypothesis. All good experiments are repeatable and should yield similar results each time.
Have you noticed that Howard can take any topic and use it to remind you that he went to space?
Interesting hypothesis. Let's apply the scientific method. Perform an experiment.
Okay. Hey, Howard, any thoughts on where we should get dinner?
Anywhere but the space station.
Created using Powtoon.